All right, this is Mr. Smith here. This is section 4.7 in Algebra 2, completing the square. Okay. And the main idea of completing the square is to be able to solve a problem like this. And so I'm changing the problem a little bit. Instead of a 25, I want to put that as a 20. And the reason will become apparent in just a moment. And so what I'd like you to do, if you're watching this at home or sitting in my class right now, is I'd like you to try to solve this problem using any of our three techniques. And I'll say three, and I'll explain them. Number one, we have a factoring technique. Okay? So I'd like some of you to attempt a factoring technique. We have a square roots method. Okay? Square roots method is very powerful, so I'd like you to try a square roots method. And obviously, we have a graphing calculator piece that we can graph and find intersection points. And so I'd like you to try those three right now. So if you're watching at home, go ahead and pause the video. And after you've tried those for a moment or two, you may hit resume. Okay, so hopefully after you've attempted the square roots technique, a factoring technique, and maybe even graphing, you've realized that you cannot get the exact answer using any of those three methods. And so we need something more. And so what we're going to do in this section on completing the square is we're going to try to rewrite this left-hand side as some quantity squared. Okay. That's the entire goal of the process called completing the square, is to rewrite this piece as some quantity squared so that I can then take the square root here, and I have maybe some number over here, so I'll use a number sign, and we can take the square root and complete the process of the square root method. Okay, so that's the idea, and let's see if we can do it. Okay. So in this case, I see I have x squared minus 8x plus 16, and that piece, this trinomial, just so happens to factor quite nicely as x minus 4 quantity squared equals 20. Okay. Again, that is to say that x minus 4 times x minus 4 is x squared minus 8x plus 16. Now, will it always work out like that? No, of course not. Okay, but for right now, I want you to see this process is that we're going to factor this left-hand side, and the goal is to get some quantity squared so that I can now use the square root method like we've seen in the previous sections. Okay, so we take the square root on both sides. Take the square root on both sides. Remember to consider both positive and negative case. And we get x minus 4 equals positive negative square root of 20. I add the 4, x equals 4 plus minus radical 20. And then the last piece is I simplify square root of 20 to be 4 plus or minus 2 radical 5. Okay. So the process of completing the square adds 2 steps or 1 step before we get to the square roots method. Let me show one more problem, and then we'll pause for a moment. Okay. So here we have x squared plus 6x plus 9 equals 30. Okay. If you try a factoring technique, if you try a graphing technique, if you try the square root method as it is, none of those three options are really viable here. Okay. But instead, if I look to write this left-hand side as some quantity squared, then I can use the square roots technique. Okay. So let's look at this. Does this left-hand side factor into some quantity squared equaling some number? And the answer is yes, it does. Okay. So I look at this, I see I have x squared plus 6x plus 9, and that should factor into x plus 3 quantity squared. Right? And you can do a little scratch work or bottom work to show, x plus 3 times x plus 3 is indeed x squared plus 6x plus 9. But we should be comfortable enough with factoring that hopefully we don't need this step. But if you do, that's fine. So I've rewritten the left-hand side as x squared plus 6x plus 9 as x plus 3 quantity squared. The 30 stays over on the right-hand side. And now again, I'm ready to use the square roots technique as we've been doing previously. So I'll rewrite this: x plus 3. Take the square root on both sides. Square root on both sides. Remember to consider the positive negative case. And that gives us x plus 3 equals positive negative square root of 30. And now last step, we subtract out the 3. And there we are. And square root of 30 doesn't simplify. Okay, so this first step here from this form up here down to this guy, that is the step or the process called completing the square. Okay, so this is from the textbook, the idea of completing the square. I'm not going to emphasize this too much, although there's a nice graphical visual understanding for those of you who are visual in nature. I'll let you spend a little bit more time here. But instead, I'd like to just build to the main idea that my students are kind of grasping at, and that is, imagine that I had this set up: x squared plus 16x plus c. Okay. And I want to write this out as something x plus some number here, quantity squared. Okay. And so the question becomes, what value does c have to be? Okay, so let me kind of put that as an orange box so we can see it. So what value does c have to be, and then what number is going to go here, and how can I figure those out? Okay. That's the question completing the square actually tries to ask and answer. Okay, so imagine I have x squared plus 16x plus some number, and I need to know, and there's only one number that could work here. Okay, there's only one value that could work there. So let's, for instance, try plugging in the number 16. Okay. So imagine that this number was 16, and it's not, that's incorrect. But imagine for a moment that it were, then for this to be some quantity squared, it would have to be the quantity x plus 4 quantity squared, because that's the only way that I could get a 16 here, right? 4 times 4 gives me the 16. But I know that if I multiply x plus 4 quantity squared out, it's not going to give me the middle term of 16x, it's going to give me a middle term of 8x. So this construct, this setup, doesn't work. Okay, so we're back to the drawing board. And so I have a live studio audience right now, so we'll try them. What number should go in the box to make this happen? Go ahead. Okay, so let's try 64. All right. So if that's 64 then this number here would have to be 8, because 8 times 8 gives me the 64. And the question is, does that give us our middle term of 16x? And the answer is yes. Okay, the answer is yes. So what kind of pattern or what kind of rule can we get out of here? How did we figure out that it was 64? Right? How do we do that? And so the answer is we look at this middle term. And if I call this middle term b, then this number here, the box number, all right, so let me switch colors. We'll go with blue. So the box number here has to be b divided by 2 squared. Okay. So whatever b is, we divide it by 2, and we square it, and that's the number that will go in the box. Okay. And then this number, how do we get this number? Well, this is just b divided by 2. It's just b divided by 2. Okay. Now, remember, don't lose context here. Our goal is to use this to solve an equation. Our goal is to use this to solve an equation, which means that if I added a 64 on one side, I'd have to add a 64 to the other side. Okay, but right now we're not quite ready to do the equation yet. We're almost there. Okay. So let me do another example just like this. Okay. And so I'll just try to find some space right here. And so imagine I had x squared plus 10x plus some number, and I want some number here so that I can write this as x plus something quantity squared. Okay, so what number has to go into the box? So what we do is we look at the middle term, we divide it by 2 and square it, so 5 squared. So this number should be 25, and then this number here has got to be 5, and that should work. Okay. And so now the goal is to put all of these pieces together into solving this equation. Okay, hang on, we're gonna keep going through the bell, just a little. Okay, so the first thing we see is that there's a 4 here, and this 4 is absolutely useless. Okay, so we just need to get it out of the way. And so x squared minus 12x equals -4. And notice I left some space in there. The reason I left some space is because we're going to add in now our number that we need to complete the square. Okay. And so the number that we should add to both sides is 12 divided by 2 squared, so 36. And I'll add 36 to both sides because remember, whatever I do to one side, I have to do to the other. And now I can factor the left-hand side as x minus 6 quantity squared equals 32. And now I'm ready to use the square roots method from here. Okay, so at this point, I'm going to leave that to you guys to finish. But the process of completing the square, let me go back through it. First we got rid of the 4, just took it to the other side. Then we chose some number to add to both sides. I added 36 to both sides so that I could write the entire left side as x minus 6 quantity squared. Okay. At this point, now we can use the square roots technique to finish the problem off. And that is the process of completing the square. So we'll take a look at the rest of this lesson tomorrow. Thanks for your attention. See you next time.